Okay. Last time, one of you has asked what will happen when both the indices of our signals are negative. And the answer was that we will be adding the indices of both the signals who has to be convolved with. Suppose one of the signals starts at -6 and the other signal starts at -5. So as a result of the convolution, the index of the resulting signal will be starting at -11. Okay? So we will be doing two examples today. And okay, so now this is an example. This is the second example. One example we did last time. So x of n is equal to u of n minus u of small n minus capital N, and h of n is equal to a raised to power n u of n. So this is the situation that we are interested in now doing. Y of n, x of n is being shoved into system which has impulse response given by a raised to power n u of n, and we are interested in knowing the generalized expression for y of n. So what is this x of n? So it has two components. One is u of n, and the other component u of small n minus capital N is subtracted from this u of n. So what is u of n? U of n starts at n is equal to 0 and it continues to the infinity, and the amplitude of this signal is 1. And u of small n minus n is what? What is this signal? This is the same signal, u of n, but now shifted to n. So it is starting from n plus 1, n plus 2, n plus 3, n plus 4, and it is continuing to infinity. And now we have to construct this x of n, and x of n is what? X of n is this signal minus this signal. So as a result of that, you are getting this one. From 0 to n minus 1, you are getting a block of samples which are getting value 1, and the rest will be equal to 0. Agreed? आपसे पूछ रहा हूँ जी, आप एग्रीड? क्या क्या कहा है मैंने? अगर मेरे कहना सुना होता तो इधर देखने की जरूरत पड़ती? प्लीज पे अटेंशन, प्लीज. So u of n minus u of small n minus capital N. So it depends on the value of n. So till n minus 1, you will be getting these values 1, sample values 1, and the rest of the values will be 0. Convinced? You know x of n, and now what is happening? That you have impulse response, and it's the same impulse response which we had used in the last example as well. Okay, you must have solved that. And yes, solve. ये आपने solve. क्यों? क्या तरीका होगा आपको फोर्स करने का? Anyways, okay जी. Now this is my h of n. It is decreasing if a is lesser than 1, and now we have to do this y of n is equal to x of n convolved with h of n, and it is nothing but k is equal to minus infinity to infinity h of k x of n minus k, or k is equal to minus infinity to infinity x of k h of n minus k. Now what is the word description of these two equations? Difference behind between these two? जी भाई साहब. Great, Zabardast, great. So you are keeping one of the signals as it is, and depending on the, this is very important, that if some signal is complex, make it as it is, and flip the other signal and drag it from minus infinity to infinity, and get this multiplication and addition. As a result of that, you will be getting this convolution summation. ठीक है ये बात? ठीक. So इस केस में आप क्या कर रहे हैं? You are keeping h of k as it is, and flipping and dragging x of k, and here you are keeping x of k as it is and flipping and dragging h of k. So now what we have to do, we are taking one of the signals. So x of k is what? X of k is this thing. Why x of k? Because just we are replacing the indices. So this was your x of n. So x of k, x of n was this thing, 0 to capital N minus 1. So that was your x of n, and the index was n. So as in equation, we are using the dummy index k. So now x of k is nothing but 0 to n minus 1. Everything is same except your index is changed, which will be vanished in the end. So k index पे x of k ban gaya. Similarly, if you are interested in doing x of, using this thing. So x of minus k will be what? 0 to, it will be flipped. यानी जो चीज यहाँ पे n minus 1 पे है वो कहाँ चली जाएगी? माइनस n minus 1 पे. जो इधर रखी हुई है जो इधर चलती जाएगी, ठीक है? और जीरो वाली जो है वो जीरो पे फ्लिप कर दिया आपने. So this is the situation. Now this is x of minus k. यहाँ पे भी अगर आपको कोई confusion हो तो please stop me. And so now at any instance n, that would be the situation. Because we are interested in y of n, so any arbitrary n, so that would be the situation. The 0 is replaced with n. The 0 is n, and here 0 was shown here as x of n minus k. So यहाँ पे जो minus n minus 1 है, that is replaced with n minus 1. Agreed? So that's the generalized kind of thing. Your flipped signal, which is now being dragged. Okay, now being dragged, and now it has at position, this index is at position n pe maujood. Okay, so that was your h of n with the condition, this was a raised to power u of n with the condition that a is less than 1. That's why it is a decreasing function. That was your h of n or h of k keh lijiye. So that would be a raised to power k, u of k, there is one, and that is index 2. Okay, and this is h of n minus k. So there will be two zones. Zone 1, when n is lesser than 0. When n is lesser than 0, there is no overlap. And when there is no overlap, when we will be solving this equation, when we'll be multiplying sample by sample, there is no overlap. As a result of that, the result of this multiplication will be equal to 0. So as a result of that, in this zone, when n is lesser than 0, y of n is equal to 0. Whenever I will be giving you this problem, you will be giving me the answer in this form. There are different zones. Okay, so now zone 2, when this n is greater than 1. So this is the situation. Okay, n is greater than 0. So n is greater than 0. Now this is partial overlap. So partial overlap के केस में क्या situation है? Y of n will be equal to, because this is the zone where we are getting the result. Multiplication में non-zero values आपको यहाँ पे मिल रही हैं. So k is from 0 to n, a raised to power k, and it is nothing but 1 minus a raised to power n plus 1, 1 minus a. कहाँ से आया ये? Metric series. And what was that? It was in fact a is equal to n1, n2. नया जो है ना ये a raised to power k, and that is nothing but a raised to power n1, the lower limit minus a raised to power n2, the upper limit plus 1 divided by 1 minus a. So here the lower limit is 0. So a raised to power 0 is 1 minus a raised to power upper limit plus 1 and plus 1 divided by 1 minus a. Clear hogi baat? So that's the case. Is there any other case in this equation? जी यस सर वाले कौन साहब हैं? यस सर वाले आप हैं? जी बोलें. जी बताएं किस वक्त कंप्लीट ओवरलैप होगा? मेरे भाई अगर ये सपोज मैं इस n को इंफिनिटी पे भी ले जाता हूँ तब n minus n किधर है n minus n minus 1? Yes, because this is a finite signal. This is a finite signal. This is not infinite signal. So this is what I have written here is wrong. So ये situation नहीं आएगी इसके अंदर. The situation is that आपके पास अब ये आ गई situation. जब आपके पास complete overlap होना शुरू हो जाएगा. ये उठा है और ये रिवर्स हुआ तो ये क्या होगा n और ये क्या हो जाएगा portion, that is n minus capital N minus 1. So it means when n minus capital N minus 1 is greater than 0, in that case we will be having complete overlap. So that's the third zone. N minus capital N minus 1 greater than equal to 0. So it means n is greater than equal to n minus 1. So इस बात का मतलब हुआ कि आपकी लोअर लिमिट क्या हो गई, अपर लिमिट जो है आपकी आप देख लें इसको, लोअर लिमिट आपकी हो गई n minus 1, अपर लिमिट n, एंड यू आर गेटिंग सॉल्व करके चेक कर लें. तो y of n is equal to n minus capital N minus 1 और upper limit n a raised to power k, and you will be solving it. ठीक है, हाथ बांध के बैठे, खोल लें हाथ. कोई कागज पेंसिल कोई चीज है? क्या नाम है आपका? असद या हसन? हसन. हसन, प्लीज स्टार्ट पेइंग अटेंशन टू दिस कोर्स. सुने, मतलब कोई ना कोई पॉइंट तो बंदा लिख सकता है ना. ठीक, एग्रीड जी? कोई कंफ्यूजन, कोई प्रॉब्लम? चले आगे. ग्रेट. नाउ एज द लास्ट क्वेश्चन आस्क्ड बाय समवन कि वो इंडेक्स वाला, तो आई हैव टेकन वन एग्जांपल, and this is another way of writing the same thing. X of n is equal to, these are the sample values, -1, 1, 0, 2. This is the same thing expressed pictorially, -1, 1, 0, 2. But the important thing is ये arrow जो लगा हुआ है, this arrow is indicating that the signal is starting from here. Actually the 0 is here. So 0 जो है वो 1 पे है और -1 जो है वो -1 पे है. ठीक है, इंडेक्स जो है वो इस तरह से इसकी इंटरप्रिटेशन है. And similarly here as well. So this is indicating the signal is starting from, this is 0, but the signal is actually starting, the index is, this index is -2, -1, this is 0, and this is 1. Similarly, this is -1, 0, 1, and 2, which is shown here. Agreed? This is another way of representing the thing. And now we are interested in knowing the numbers. Y of n. Y of n है तो numbers होंगे, आपके samples इसी तरह के signals आ रहे होंगे. So what will be the total number of samples in the resultant Y of n? Hassan, how many samples? Great. So 4 plus 4 minus 1, that would be 7. And what will be the starting index of the resultant signal? Minus 3. Start of the one index, starting index of the one signal plus starting index of the second signal. So the -1 plus -2, these are the indices. So -1 plus -2, that would be -3, and we have to solve one of these equations. ठीक है जी? So let's do it. So this is my x of k. So it means I will be making x of k as it is, and I will be flipping my impulse response h of k and dragging it from -infinity to infinity. X of k is nothing but x of n. The only difference is that I have replaced the indices. So k यहाँ पे आ गया. So otherwise there is no difference in that. And h of minus k, because initially I have to take, to get h of n minus k, I will be taking h of minus k. So h of minus k is what? H of minus k is flipped around 0. So this was my h of k. So h of minus k will be flipped. जो -2 पे चीज पड़ी हुई थी वो 2 पे चली गई है, जो -1 पे थी वो 1 पे आ गई है, और जो 1 पे थी वो -1 पे आ गई, जो 0 पे थी वो 0 पे ही रही. So that's my h of minus k. And now the important thing is कि कहाँ से start किया जाए, because we have to take from minus infinity to infinity, but we know there will be certain zones, there will be no overlap, and I'm not interested in those because there I will be having the value 0. So the first non-zero value I will be getting at minus 3 because we said that minus 3 पे start होगा. So this is clear here that minus 4 पे y of minus 4 जो है वो वैल्यू जो है वो 0 आ रही है. और किस तरह से we can confirm it. So minus 4 अगर मैं इसको देखता हूँ so this is in fact y of minus 4 h of minus 4 minus k. तो क्या हुआ, जो 0 पे जो चीज पड़ी हुई थी वो minus 4 पे आ गई है. इधर गए हैं. ओके, जो 0 पे चीज थी वो minus 4 पे है, जो minus 1 पे थी वो minus 5 पे है, जो 1 पे थी वो minus 3 पे है, जो 2 पे थी वो minus 2 पे है. ठीक है, minus 4 किया है. So in that case, if you look at this x of k multiplied with h of minus 4 minus k, तो क्या रिजल्ट होगा इनकी मल्टीप्लीकेशन का? 0, बिकॉज -1 पे यहाँ पे 0 है, सो -1, अदरवाइज बाकी सैंपल्स पे इधर 0 है और यहाँ पे इधर इस साइड पे 0 है. तो -1 पे देख लीजिए, -1 पे यहाँ 0 है और -1 पे यहाँ -1 है, अदरवाइज तो बाकी ओवरलैपिंग वैसे भी कहीं नहीं है. तो दैट रिजल्ट विल बी 0. -3 पे अगर हम जाते हैं तो -3 पे देखते हैं क्या होता है. So this would be -3 now. ये -4, ये -2, ये -1, 0, 1 and 2. Now here, now this is h of -3 minus k. The first non-zero value, we are convinced that the first non-zero value should come here. So -1 है, यहाँ पे -1 पे -1 है. You will be multiplying 1 with -1. As a result of that, you are getting the result h of y of -3 is equal to -1. Then you will be dragging more towards the right. -2 पे लेके आएंगे. तो -2 पे लेके आएंगे तो अब क्या सिचुएशन हो जाएगी? दिस इज -2, -3, -1, 0, 1, 2, 3. Now there are two samples which are overlapping. One is at 0 and the other one is at -1. 0 पे 1 into 1, it is 1, plus 2 into -1, which is -2. So 1 plus -2 is equal to -1. Similarly, y of -1 के लिए अगर हम जाएं, so this would be -1, -2, 0, 1 and 2. How many samples जो कि उसमें है ओवरलैपिंग में 3 सैंपल्स हैं. 1 will be multiplied with, जो 1 पे है 1 will multiplied with this 0, 0. उसके बाद 2 will be multiplied with this 1 because that's on index 0 plus 2, and this -1 will be multiplied with this 0 which is at -1, 0. So that's the result of 2. So finally इसी तरह से आप इसे आगे लेके जाएंगे और कहां तक आपको नॉन जीरो वैल्यूज मिलेंगी? y of three तक, because you have already said that we will be having how many samples? 7 samples. We have started from -3 towards +3. तो -3 से +3 तक आपके पास इस कन्वोल्यूशन का रिजल्ट होगा. y of -4 और y of 4 जो है 0 है, रेस्ट ऑल आर 0. क्वेश्चंस प्लीज. ऑनलाइन स्टूडेंट, एनी क्वेश्चन बेटा?
अस्सलाम वालेकुम सर.
जी बेटा, अपना नाम बताइए.
सर अब्दुल मजीद बात कर रहा हूँ सर.
जी अब्दुल मजीद बोलिए.
सर ये जो ट्रायंगुलर मेथड होता है सर, उस मेरे ख्याल से ये चीज़ सेम नहीं उसी से मैच हो रही सर.
ट्रायंगुलर मेथड ये कोई नई चीज है बेटा, मैंने नहीं सुना हुआ ट्रायंगुलर मेथड.
सर मुझे उसका एग्जैक्टली नाम नहीं आता, शायद मैं उसका नाम गलत बोल रहा हूँ सर. वो मैट्रिसेस बना के ना सर उस तरह सॉल्व करते थे.
ठीक है, तो उस तरह से कर लें, कोई ऐसा मसला नहीं. बट the concept behind any method will be this equation which is before you, that is the convolution summation equation. ठीक है, आप कन्विंस कर लें, उस मेथड को देख लें कि वो इसी इक्वेशन को, आई हैवंट सीन दैट मैट्रिक्स वाला, आप वो देख लीजिए। देयर इज अनदर वेरी सिंपल वे एज वेल, उसको भी आप देख सकते हैं। तो व्हाट आर द वैल्यूज, लेट्स मूव दैट। ज्यादा आसान तरीका मौजूद है विच इज -1 1। वो जनरली वो मेथड्स जो है वो 0 इंडेक्स पे जब होना चीज तो वो ज्यादा बेहतर चलते हैं। सपोज हम स्टार्ट करते हैं, हम कहते हैं कि हमारे पास दो सिग्नल्स हैं which are 1 2 3 and 4 and it is starting at 0 and the second one is 2 5 3, ठीक है, and that is starting from here. So अगर इस तरह की सिचुएशन हो तो you can use this. So 1 2 3 4 2 5 3 मैं यहीं पे ही कर देता हूँ। देखिए इधर ही कर लें, चलिए इधर ही कर लेते हैं। So 1 2 3 4 and 2 5 3 2 5 3 will be flipped, so that would be 2 5 3, ठीक है। So the result of the convolution will be something like that. So पहला रिजल्ट आपको कहाँ पे मिलेगा, यहाँ पे मिल गया पार्शियल ओवरलैप का। नेक्स्ट टाइम क्या होगा, नेक्स्ट टाइम 2 5 3। नाउ व्हाट विल बी द रिजल्ट, 4 + 5 2 + 4 9 हो गया। नेक्स्ट क्या स्टेप होगा, दैट वुड बी 2 5 3। व्हाट आई एम डूइंग, आई एम अगेन ड्रैगिंग इट, फ्लिपिंग एंड देन ड्रैगिंग इट, और मैंने नॉन ओवरलैपिंग से स्टार्ट कर दिया रिजल्ट बनाना। सो 6 + 10 16 + 3 19। There is a possibility that I make some error, but that's the situation. So 8 + 15 13 15 8 23 23 + 6 29, and then finally it will be 5 3 20 + 9 29 3, that's it, and after that it will be flashed out. Another way of doing it. ठीक है बेटा मजीद,
सही है सर।
उसको कर सकते हैं, लेकिन उस केस में आप कंफ्यूज हो जाएंगे। मैं इस वजह से ये एग्जांपल जो है ना वो इस तरह नॉर्मल तरीका जो है कि कैसे आपने कन्वोल्यूशन समेशन को, अदरवाइज करने को तो कोई ऐसा प्रॉब्लम नहीं है। इसी तरह फ्लिप एंड ड्रैग से आप -3 इंडेक्स को ब्रिंग लाना जो है ना इसके अंदर, वो थोड़ा सा कंफ्यूजन हो जाएगी। फिलहाल आप इसी तक महदूद रहें, ठीक है। बाद में जब आप जरा थोड़ा एक्सपर्ट हो जाएंगे तो यू कैन डू इट बाय योरसेल्फ। जी आपका क्वेश्चन हो गया, ओके। So till now what we have done, we have discussed the discrete, continuous and digital nature of the signal. What is discrete signal? Discrete points पर values होते हैं। What's the difference between discrete and digital? Quantized होते हैं। Great, जबरदस्त। LTI systems की हमने बात की, तो LTI systems are linear time invariant systems. What is linearity? If you have stopped whirling your mustaches, please ask me. Yeah, please answer me. जी, great. Superposition को जो follow करें तो वो क्या होंगे, linear system होंगे। And what is superposition? Additivity and scaling. So अगर कोई system follow कर रहा है additivity और scaling को, तो in that case किधर खो जाते हो यार तुम? नहीं, मुझे सुनना तो और बात है, तुम तो यूं बैठे हो ना, यूं आता है ये वक्त सब पे, हम पे भी आया था। कोई बात नहीं यार, हिम्मत रखो, अल्लाह ताला बेहतरी करेगा। फिलहाल जो है ना इधर पिछली स्लाइड के बारे में, पीछे के बारे में सोचोगे तो पत्थर के बन जाते हैं, हमने तो यही सुना है। आगे ही आगे, ठीक है, ओके। सो व्हाट इज टाइम इनवेरियंस? आई एम लाइक दिस यार, थोड़ा सा मैं जरा लोगों को भी एनर्जाइज करना होता है, और तुम्हें तो जरूर करना होगा कि तुम जिस तरह से बिल्कुल वेवर्ड हो जाते हो किसी वक्त, प्लीज कॉन्सेंट्रेट। या तो मेरी आंखों में देखो या फिर स्लाइड पे देखो। तो फर्श पे देखना तो बड़ी गलत अलामत है, अच्छी तो नहीं है। Time invariance, what is that? Jitna aap, there is invariant, the response of the system is invariant to the shift. Jitni shift aa rahi hai aapke input pe, utni hi shift aapki output pe chali jayegi. So that's your shift invariance or time invariance. What is impulse response? As we discussed, that you throw an impulse to the system, what will come out? That's the impulse response of the system. Very important thing, because what was inside the system, that would come out. What is the characterization of the system shown through this impulse response? And for an arbitrary input, you know the impulse response, so you will be convolving x of n or the arbitrary input with your impulse response, and you will be getting your output through convolution. And convolution के बारे में तो अब आप expert हो ही गए, ठीक होगी बात? Okay, we did, yesterday we discussed this. No, yesterday तो आपकी class ही नहीं थी. Okay, so the linear time invariant systems, the convolution property holds for associativity and distributivity. This is what? This is कि अगर आपके पास एक ऐसा system है, which is x of n is being thrown into this system, and there is another system cascaded with that. So there are two ways. Either you convolve this system x of n with h of n and get some output, and then convolve that output that would be acting as input to this system. So you will be convolving that with this system and getting your y of n. There is one way of doing it. But there is another way of doing it, because of the associative property of convolution, that you collapse these two systems together. And the collapsing will be done through convolution of this system with this system. H1 of n, impulse response of this system, will be convolved with impulse response of the second system, and you will be getting resultant force H3 of n, and that H3 of n will be here, and then you will be throwing an x of n, convolving H3 of n, and getting the output, and that output will be similar to what you have obtained here. Agreed? And there is another possibility, that your systems are in parallel. Here the systems were in series. So agar is tarah ki situation hai, the distributive property will come into action. Either you convolve x of n with h of n and obtain some value, and then convolve x of n with h2 of n and obtain some value, and add both of these outputs together to get the y of n. Either you do this way or collapse the system h1 of n and h2 of n, and this time the collapsing will be done through adding the system, adding the impulse response of the system, sample by sample, h1 of n plus h2 of n. Okay? And then you will be getting the resultant signal by collapsing these two systems, and then x of n will be convolved with this collapsed system, and you will be getting y of n. And both the cases, your output will be same. Agreed? Koi confusion? Okay. So again, this is a convolution example, but self convolution hai rectangle ki. So this is a rectangle. It's the same signal which we have talked about. X of n is equal to u of n minus u of n minus capital N, and if capital N is equal to 6, you will be getting this signal. Okay? So this is your signal. 0 से 5 तक आपके पास non-zero samples हैं, rather the sample values are 1, and before and after the value is 0. So it's a finite signal, and you know whenever we have a finite signal, okay. So what will happen? There will be a zone when there will be no overlap, फिर उसके बाद partial overlap start होगा, और इसी तरह से फिर उसके बाद full overlap होगा, फिर partial overlap होगा, और फिर no overlap होगा. So that's the signal. Index of one signal is 0. The index of the second signal, because we are using the same signal to be convolved with this one. So both the indices are 0. So the resultant signal की जो index होगा starting, वो भी 0 पे है. The number of samples in this signal are 6. So the number of signals and the resultant signal will be 6 plus 1 minus 1. ये 11 samples हैं आपके पास. ठीक है? ये एग्जांपल आपने सिग्नल्स एंड सिस्टम्स में भी देखी होगी, अगर पढ़ा हो तो. पढ़ा ना? देखी थी एग्जांपल. Okay. So these are the things to remember. Convolution. One signal is infinite and the other signal is finite. To answer how many zones to answer about the convolution result, you have to take in mind that there will be 3 zones. One zone is there will be no overlap because you have kept one signal which was infinite, you have kept it as it is, and there was infinite signal, you have flipped it, you have brought that to negative infinity or minus infinity, and then you have started dragging it. There is a zone when there is no overlap. Then it will be partial overlap, and then there will be full overlap. This is equivalent to what we had done here. No overlap, partial overlap, and full overlap. There were 3 zones. Similarly, both the signals are finite. We have 5 zones. No overlap, partial overlap, full overlap, then again partial overlap, and no overlap. Where we have seen it? We have seen it here in this example. There are 5 zones. So this is a zone of partial no overlap. Then this is coming from, these are the values coming from partial overlap. Now this value is coming from full overlap. Again, these values are coming from partial overlap, and these values are coming from no overlap. So 5 zones. And there is a case when both signals are infinite. Okay, both the signals are infinite. We have 2 zones, no overlap and partial overlap. There will be no time on earth that there will be full overlap of the 2 infinite signals. Agreed? We have done it. Before moving to this thing, stability, मुझे टाइम बताइए. और ये 11:25 तक होता है. Okay. Let's keep it here. मुझे ये बताइए the people online. मैं इसे कल रिपीट तो नहीं करना पड़ेगा मुझे, बिकॉज आज सिंडिकेट सी के लिए मुझे आधे लेक्चर को दोबारा रिपीट करना पड़ा है. The people sitting there, have you got everything related to this? अभी कोई जवाब नहीं आएगा. अटेंडेंस लेना शुरू करूंगा तो आवाज भी आना शुरू हो जाएगी, हर चीज ठीक हो जाती है. यार कम ऑन, यू आर ग्रोन अप पीपल. जी बेटा, आई एम आस्किंग फ्रॉम यू.
यस सर, क्लियर है.
ठीक है बेटा, एवरीथिंग इज फाइन.
यस सर.
सिर्फ आप लोग हैं, बोलते जाए ना ताकि मुझे अंदाजा हो जाए. एनी कंफ्यूजन, एनी क्वेश्चन?
यस सर, क्लियर है.
हसनात,
कोई क्वेश्चन?
आप इसी क्लास में? नहीं, हसनात नो प्रॉब्लम. सो टुमारो आई विल नॉट रिपीट दिस पोर्शन फॉर श्योर. ठीक है हसन? ठीक है. नहीं, आप तो कल उस पे होंगे ना, तो आपको तो क्वेश्चन वैसे ही कोई नहीं होना. इधर नहीं बैठे हुए नहीं है तो उधर कहाँ से होगा. जी बोले प्लीज. दो जोन को देखो, अगर सपोज एक सिग्नल है u of n, ठीक, सपोज वन ऑफ द सिग्नल x1 of n है u of n, एंड द सेकंड सिग्नल x2 of n है u of n. सपोज हो सकता है ना, हो सकता है ना. तो क्या करेंगे हम एक सिग्नल को उसी तरह से रखते हैं, दूसरे को फ्लिप करते हैं, तो क्या सिचुएशन डेवलप हो रही है. नाउ दिस इज माय u of n. मैं कंटिन्यूअस डोमेन में बात कर रहा हूं, बट एक्चुअली दीज आर डिस्क्रीट सिग्नल्स. दूसरे सिग्नल को मैंने फ्लिप किया, तो फ्लिप किया तो ये सिचुएशन आ गई, ये सिचुएशन आ गई. अब क्या होना शुरू हो जाएगा. सो ये तो नो ओवरलैप वाला जोन था. फिर उसके बाद पार्शियल ओवरलैप. ये चलता जाएगा, ये चलता जा रहा है, ये चलता जा रहा है, चलता जा रहा है. फुल ओवरलैप कहीं फर्स्ट. फिर आइडियली ये सिचुएशन है कि ये चलता जा रहा है. अगर ये इंफिनिटी पर भी जाता है तो ये तो चल रहा है ना पीछे. उस केस में आपके पास कितने जोन है? 3 जोन है. उस केस में 3 जोन है, वो तो बात हो चुकी है। 3 जोन, नो ओवरलैप, पार्शियल ओवरलैप, फुल ओवरलैप। बिकॉज ये अगर फाइनाइट है तो इस केस में ये वाला जो पोर्शन है ये फुल ओवरलैप का पोर्शन है। ठीक हो गई? ओके, तो वी कीप इट हियर ताकि मामलात जो हैं अंडर कंट्रोल रहें। So tomorrow we will be starting from stability, and if you are interested you can study it from your books as well. थोड़ा सा वैसे तो क्या बात करनी इस बारे में, लेकिन anyway अगर आप पढ़ना चाहें तो पढ़ सकते हैं। Lecture will be there.